All right, so we're starting off our factoring here. And factoring is a huge topic, but it all begins with the exact same idea, and that is the greatest common factor. So we are going to end up using our math facts, our multiplication facts, to come up with this. And then that's all it simply is. It's a lot of guess and check when it comes down to it. A lot of, well, this works. Okay. Anything else? No, nothing. Nothing else. We're done with it. So let's get to the very basics of factoring. Question number 1. Let's say we have 6x plus, and we can say something like 20. Now, it's called factoring because what a factor is two numbers multiplied together. So, for example, 5 times 6 equals 30. So in a multiplication problem, you have 2 factors. You've got 5 and you've got 6. Now, there are other factors of 30. 15 and 2, because 15 times 2 gives us 30. 10 and 3, because 10 times, those are factors. So rewriting as a multiplication problem. So to do that, we're trying to find a number that's in common. In other words, common that we can divide them both by. So the biggest number that you can divide 6 and 20 by. And this is where we talk about just going through multiplication facts. And sometimes when you don't know what to use, we realize they're both even numbers, so we start with a 2. So what we're going to do is we're going to divide them both by 2. So if I take 6 and divide it by 2, we get a 3, so it's a 3x. I take a 20 divided by 2, and I get a 10. And we're done. Now, how do I know I'm done? Well, look who's inside the parentheses. There's a 3, and there's a 10. There's no common factors here. The only numbers I can divide 3 by is 3. We don't use 1 because 1 doesn't help us. It's like spinning in a circle. It might be fun, but it's not going to get us anywhere. And 10, well, okay, 2, but 3 doesn't work with 2. And 5, I can't divide with a 5. So that's how I know I'm done. And again, you can see our factor. It looks awkward, but remember, a number up against parentheses means to multiply. So I do have my multiplication symbol. And like up here, I had a 5. Well, over here, I've got a 2. What makes this awkward is yeah, I got a number 6 over here. It just happens that it's 3x plus 10. So again, that's all factoring is. It's rewriting as a multiplication problem. Some students view it as the reverse distributive property. Because if we use our distributive property and check it, 2 times 3x does give us 6x. 2 times 10 does give us 20. We know where they're safe. Let's try another one here. So question number 2. Let's go after 18x minus 24. So again, we're just trying to come up with the biggest number we can divide them both by. And the thing here is if you say 2, because you're like, they're both even, so let's just use 2. Well, watch what's going to happen here. 18 divided by 2 is 9, so it's a 9x. 24 divided by 2 is a 12. Here's the thing. We can still divide more. I can still divide 9 and 12 by someone. And so because of that, I know I haven't gotten the greatest common one. So what I suggest doing here is try to, playing with that 2, we're just going to start over. But here's the thing. We can actually use this to help ourselves out. Who can you divide 9 and 12 by? Well, it's a 3. So if I use the 2 and I use the 3, we can multiply here. 2 times 3, 6. So what that tells me is 6 is a probably better location to go to. So I'm going to try my 6 here. But again, I'm not using this guy anymore. I'm going back to it. 18 divided by 6, 3. There's my 3x. 24 divided by 6, 4. And we're done. 3x minus 4, because there's nothing in common. Now, hey, if you saw 6 right away, phenomenal. All right, the goal is to grab that largest one. But if you don't feel like you've got to sit there. Try, use something basic, and then realize you're going to have to end up factoring again. But instead of trying to play with that 2 and that 3, just realize multiply it and go right back to the beginning. Students typically find that it's easier to work from that mindset. All right, let's try question number 3. And again, greatest common factor is what we're after. So let's try 5x minus 35. Now the nice thing about this particular problem is 5. The only number you can divide by 5 is 5. So that's the only spot I can work off of. So what do you multiply 5 by to get to 5x? We can think like that. You can say x, or you could say what's 5 divided by 5, like this in the previous problems. It's a 1. Remember though, we just don't put the 1 in front of a letter that's by himself. It's understood that if I only have one x there, that there's a 1 that's there. And we'll take care of the next one. 35 divided by 5, 7. So we're done. And again, we can check it by that distributive property. 5 times x, 5x. 5 times 7, 35. Voila, we've got it. Now the only thing that kind of slips into our factoring here is sometimes the letters show up, because sometimes we have a letter that's in common. So let's try something like this. 4x squared minus 10x. So we do have, start with the numbers, the 4 and the 10, and that's just business as usual. Ooh, what can you divide them by? Well, 2. All right, so that part's the same, but we also notice that we have variables that are in common. We've got x's that are there. So the general rule here is you take the lowest of the letters. So there's an x squared, there's the x. When you look at the exponents, the lowest one is just your x. It's the smallest one because it has to be what's in common. So that's the general rule of, we tell, let's say for example, well, let's just say it, all right. Let's say this was a 5. Let's say it was x to the 5th power. Now who's the smallest? Well, then we'd be using the 2. So, but yeah, we'll get into that here in a moment. We'll see one in the next one. So when we look at this, I can divide them both by 2, and I can divide them both by x. And so we can go through our numbers. 4 divided by 2 is a 2. And this is where sometimes students, instead of thinking of it as a division problem, students with their letters think of what's missing. I got to get to the 2nd power. I've got 1. Oh, so I need 1 more. Because I have an x and I have an x. X times x does give me my x squared. And then minus 10 divided by 2 is your 5. And I've already got an x. I only need an x. So I don't need anyone else. And again, I think this is when you're thinking of it as the distributive property. If you're not sure, it makes 2x times 2x. So 2 times 2 is 4. X times x, x squared. 2x times 5. Well, 5 times 2 is 10. The x comes along for the right. I got my 10x. So we're going to see a lot of that where just make sure. Double, yeah, okay, yep, I got it. That's your mindset. Let's look at another one here with a few variables. So let's go after someone like 3x cubed plus 7x to the 5th power. Now in this particular case, there aren't any common factors for the 3 and 7. We just leave it alone then. Let's look at the letters. X to the 3rd, x to the 5th. Now, like I said before, you are taking the smallest one. And the reason why is because it's what we have in common. If we come off to the side and rewrite what x to the 3rd power looks like, it looks like x times x times x. And we look at what x to the 5th power looks like. Oops, that's too big of a 5. Let's try that again. That's going to be x times x times x times x. That's 4 of them, and I need 1 more to make 5. So we look at what we have in common. Well, what do we have? We've got 3 of them and 3 of them. So that's the behind the scenes action, and that's why we just say just grab the smallest one. So x to the 3rd power is the greatest common factor here. So we can think of it as a division problem, or like I said, sometimes it makes it easier to look at is what do you multiply by? What do you multiply x cubed by to get to 3x cubed? Well, that's just the 3. What do you multiply x cubed by to get to 7x to the 5th? Well, I need my 7. And then with the exponents, I need to get to 5. I've got 3, which means I need 2 more. And there we go. It looks awkward as an answer, but remember, it's factoring. So x to the 3rd times 3 plus 7x to the 2nd. There's my 2. And again, it goes back to the basics. 30. 5 and 6 are factors because you can multiply them together. We're just going to give you 2 to try by yourself here. And then that'll be it. So for question number 6, let's try something like 8x plus 12. And then for question number 7, let's try something like 10x squared plus 25x cubed. Hit that pause video and try it. All right, so let's do question number 6 here. The greatest number that's in common, it's a 4. And again, think of it as a division problem, or what are you multiplying to get back to where you started from? Kind of your choice on how much you like that distributive property. I'm a distributive property fan. I know. Not the leader of the fan club, but I still like it. That's going to be a 2x, because 4 times 2 gives me 8. And then that's just going to be a 3, because 4 times 3 gives me 12. I'm done. 2x plus 3, can't do anything else with it. Nothing else to divide by. Let's look at question number 7. I've got numbers and letters in common. I can divide them both by 5. And not only that, I've even got letters that are in common. I can go out to x squared. So the idea is what do you multiply 5x squared by to get to 10x squared? It's just a 2. Again, I can think of it as a division problem, but that seems to be a lot more work as what's 10 divided by 5? What's x squared divided by x squared? And then what do you multiply by? Well, it's just the 5x. 5 times 5 is my 25. X to the second, I need to get to x to the third, so I need 1 more. So there's my x. And there we go. Nothing with that 2 and that 5x. So that way I know I'm done with them. All right, there's your basics. Talk to you later.